guys, it's me again, Angie, and for today's video, I'm going to discuss you about network protocols and communication in chapter 3. This chapter began with a review of layer 2 switching. This included a look at how a switch segments a network into a number of smaller collision domains, as well as how a switch makes full duplex communication possible. This was followed by a look at the different switching methods supported by Cisco, including store and forward, cut-through, and the default for the Cisco 1900 series fragment-free. A look at redundancy and loop avoidance explained the benefits of having multiple paths on a bridge or switch network, but also the potential problems this introduces, namely broadcast storms. The process by which a broadcast storm happens was also discussed step by step. Loop avoidance for bridge networks was covered in an overview of the spanning tree protocol. The process by which switches elect a root bridge, choose root ports, and designated ports were also illustrated with examples. The 4 spanning 3-port states, listening, learning, blocking, and forwarding, were also discussed. A look at VLANs provided an overview of the benefit they provide in segmenting a network into multiple broadcast domains in a switched environment. The VLAN trunking protocol, or the VTP, was introduced as a way to easily configure VLANs on switches across a VTP management domain. VTP pruning was also discussed. For the objectives of learning this chapter, for rules of communication is to describe the types of rules that are necessary to successfully communicate. For network protocols and standards, explain why protocols are necessary in communication, explain the purpose of adhering to a protocol suite, explain the role of standards organizations in establishing protocols for network interoperability, and to explain how the TCP or IP model and the OSI model are used to facilitate standardization in the communication process. So, more and more, it is networks that connect us. People communicate online from everywhere. Conversations in classrooms spill into instant message sessions, chat sessions, and online debates continue at school. New services are being developed daily to take advantage of the network. Rather than developing unique and separate systems for the delivery of each new service, the network industry as a whole has adopted a developmental framework that allows designers to understand current network platforms and maintain them. At the same time, this framework is used to facilitate the development of new technologies to support future communications needs and technology enhancements. Central to this developmental framework is the use of generally accepted models that describe network rules and functions. So within this chapter, we will learn about these models as well as the standards that make networks work and how communication occurs over a network. People exchange ideas using many different communication methods. However, regardless of the method chosen, all communication methods have three elements in common. The first of these elements is the message source or sender. Message sources are people or electronic devices that need to send a message to other individuals or devices. The second element of a communication is the destination or receiver. The destination receives the message and interprets it. A third element, called a channel, consists of the media that provides the pathway over which the message travels from source to destination. So communication begins with a message or information. Then it will be sent from a source to a destination. The sending of message, whether by face-to-face communication or over a network, is governed by rules called protocols. These protocols are specific to the type of communication method occurring in our day-to-day personal communication. The rules we use to communicate over one medium, like a telephone call, are not necessarily the same as the protocols for using another medium, such as sending a letter. Message encoding. One of the first steps to sending a message is encoding. Encoding is the process of converting information into another acceptable form for transmission. Decoding reverses this process in order to interpret the information. Encoding also occurs in computer communication. Encoding between hosts must be in an appropriate format for the medium. Messages sent across the network are first converted into bits by the sending host. Each bit is encoded into a pattern of sounds, light waves, or electrical impulses depending on the network media over which the bits are transmitted. The destination host receives and decodes the signals in order to interpret the message. For message formatting and encapsulation, when a message is sent from source to destination, it must use a specific format or structure. Message formats depend on the type of message and the channel that is used to deliver the message. So, these are the protocol interaction. Communication between a web server and a web client is an example of an interaction between several protocols. The protocols includes HTTP, TCP, IP, Ethernet, by which HTTP is an application protocol that governs the way a web server and a web client interact. HTTP defines the content and formatting of the requests and responses that are exchanged between the client and server. Both the client and the web server software implement HTTP as part of the application. HTTP relies on other protocols to govern how the messages are transported between the client and server. TCP is the transport protocol that manages the individual conversations. TCP divides the HTTP messages into smaller pieces called segments. These segments are sent between the web server and client processes running at the destination host. TCP is also responsible for controlling the size and rate at which messages are exchanged between the server and the client. IP is responsible for taking the formatted segments from TCP, encapsulating them into packets, assigning them the appropriate addresses, and delivering them to the destination host. Ethernet Ethernet is a network access protocol that describes two primary functions, such that communication over a data link and the physical transmission of data on the network media. Network access protocols are responsible for taking the packets from IP and formatting them into transmitted over the data. So, Internet standards includes Internet Society, Internet Architecture Board, Internet Engineering Task Force, Internet Search Task Force, Internet Corporation for Assigned Names and Numbers, Internet Assigned Numbers Authority. Internet Society Internet Society is responsible for promoting the open development and evolution of Internet use throughout the world. Internet Architecture Board, or the IAB, develops, updates, are responsible for the overall management and development of Internet standards. Internet Engineering Task Force develops, updates, and maintains Internet and TCP or IP technologies. This includes the process and documents for developing new protocols and updating existing protocols, known as requests for comments or the RFC documents. Internet Engineering Task Force, and then Internet Research Task Force, focused on long-term research related to Internet and TCP or IP protocols such as anti-spam research group, crypto forum research group, and peer-to-peer research group. Internet Corporation for Assigned Names and Numbers, or the ICANN, based in the United States, coordinates IP address allocation, the management of domain names, and assignment of other information. Use TCP or IP protocols. So, as a summary of the whole, this chapter explains how rules are used to facilitate communication, explain the role of protocols and standards organizations in facilitating interoperability in network communications, and it explains how devices on a LAN access resources in a small to medium-sized business network. So, that is all for today, and thank you for watching. See ya on my next video. Bye!